Hello, everybody, and welcome. Today we are talking about Chapter 4, Investigation 2. So yesterday we talked about corresponding sides and angles and comparing similar figures. Now today we're going to be looking at scale factor. So first things first, I'm going to go ahead and write my name here to get started. Now I'm good to go. All right, I want to zoom in here so it's a little bit easier to see. And so we see the learning target for today up top. I can determine the scale factor in similar figures. And so remember, with scale factor, that is the number we use to multiply the lengths of a shape to stretch it or shrink it. Now, notice here, it says stretch or shrink. In order to make a shape bigger or stretch it, we're going to have to multiply by a number bigger than 1. For example, we see down below, we're multiplying each side by 3. And when we multiply each side by 3, our numbers are going to get larger. And so instead of just being a side length of 2, the side length is now 6. Or instead of just being 5, it's now 15. And so my shape looks a lot bigger on the right side because we're scaling it up. Now, you could multiply by a number less than 1, by like a half or 1/3, and then your numbers would actually get smaller. And so that's where that shrinking aspect comes into play. Now, one quick reminder, when we look at these two images here, it shows that we're going from the shape on the left over to the shape on the right. And so the shape that we're starting with is always going to be the original, or the OG, I like to call it. And it's going to be going over to the image. All right, this is like the image. If you were to look into a mirror, you'd see a mirror image of yourself. You could also think about it as a copy. All right, so image or copy. And when we solve for scale factor, this is how we do it. So to find the scale factor here, in other words, what we multiply each side by, we have to do the opposite of multiplying, which is division. And so I would say, okay, SV aligns with LO. SV aligns with LO. And so I write it as my copy, or my image, you could say. You'll see it both ways, over my original. So I have my copy side, SV, over my original side, LO. And so that would be 15 over 5. And then if I divide 15 by 5, it gives me 3. So I multiply each side by 3. And we can test this out by looking at another side, ST over LM. Again, that's my image over my original. And that can be 6 over 2, which again reduces to 3. So I'm multiplying that side by 3 as well. So that's how I get my scale factor of 3. It's when I'm multiplying each side by, and I figure that out through division of the image over the original. So you have to pay attention to which direction that arrow goes, because that arrow is going to tell you where you start. Your start is always going to be wherever the arrow starts. Notice it starts over here on the left side, and then your end or your image is going to be wherever the arrow is pointing. So this is going to be my image. All right, let's go ahead and scroll down. All right, so here it explains how the scale factor is 0.5. And so you're like, wait, but our shape is getting bigger, right? But notice the arrow, it starts here. So this is going to be the original. And then my arrow ends over here. So this is going to be my image. It doesn't always have to go from left to right. It's all about where are you starting and where you're ending. Now, if you didn't have this arrow here, then you would assume to start on the left side, but we do have an arrow there. So it tells us where we're supposed to start. All right. So again, since this is our image over here, I would take 8 and put it over 16. I would take 9, put it over 18. And I would take 6 and put it over 12. That is my image over my original. You can also think about it as my new over my old. All right. So here, 8 divided by 16, 9 divided by 18, and 6 divided by 12. It's going to give us 2. Oh, excuse me. It's going to give us 0.5. I was getting a little ahead of myself there. 0.5, 0.5, 0.5. Right? Because 6 over 12 would reduce to 1/2, which is 0.5. So to find the scale factor, you need to divide the image by the original. And it gives you a scale factor of multiplying by 0.5 to get from your original to your image, to get from 16 to 8, for example. All right, let's go ahead and scroll down. Now notice the order is important. So we take a look at the arrows here. If we go from 1 to 2, like we see in this first example here, then the scale factor is going to be larger than 1 because our shape is getting bigger going from where the arrow starts to where the arrow ends. Go from 1 to 2. So our scale factor would be 2. And then if we look at the second example, if we're going from 2 to 1, then our scale factor is going to be less than 1, right? Instead of being 2 over 1 up top or just 2, it would actually be 1 over 2 if we're going from 2 to 1. So a smaller scale factor. Because here it only makes sense to multiply by a number that's less than 1 to get to a smaller shape, right? This is larger. We start here, and we're getting smaller. All right, so let's go ahead and practice a little bit. So here we're starting here. So this is going to be our original. And then we're ending over here. So this is going to be our image. So we have to multiply each side by what? Well, let's go ahead and find out. So we have 16 over 20, or 16, sorry, over 4. We have 20 over 5. So 16 over 4 would reduce to 4. 20 divided by 5 would give me 4. So it seems I have to multiply each side by 4. That's my scale factor. So scale factor is just another word for multiplier. All right, here we're starting on the right side. So it's the same problem, except this time we're starting with the figure on the right. This is our start, our original, and this is our image. So now we're going to do instead 4 divided by 20 and 16 underneath. Whoop, made a mistake here. Here we're going to do 5 over 20 and 4 over 16. So here we have 5 divided by 20 gives us 0.25, or we can think about it as 1/4. And then 4 over 16 gives us 0.25, again, 1/4. So our scale factor would be to multiply each side by 0.25. All right, and notice it's just the opposite. Because up top we had scale factor of 4, which is equivalent to 4 over 1. And now our scale factor is 0.25, or 1 over 4. So notice it's just flipped when we go from the right side to the left side, or the left side to the right side, because it's the same figure set. All right, so now we're going to identify the scale factor of each pair and explain whether the scale factor should be greater or less than 1. So here we're going from a smaller shape to a bigger shape. So my scale factor is going to be greater than 1 because my shape is getting larger. We call that stretching or enlargement. and then identifying the scale factor, we're going from 6 to 12, so I'm going to write it as 12 over 6. And we're going from 4 to 8, so I'm going to write it as 8 over 4, right? Our image over our original. So both of these would reduce to 2. So our scale factor would be 2. We multiply by 2. All right, here we go. Same thing here. So we're going to look at where we start. It's going to be on that left side. So this is going to be our original. This here is going to be our copy or our image. So we're getting from 14 to 7. But remember, I'm going to have to write that as my image over my original. So if we're going from a larger shape, right, big to small, then we're going to be at a scale factor less than 1 because you have to multiply by something less than 1 to get smaller. It gets smaller. That's my reasoning. So we have 7 over 14 we reduce to 0.5 or 1/2. And then we have 8 over 16, which would again reduce to 0.5 or 1/2. And then we have 5 over 10, which again would reduce to 0.5 or 1/2. So we have 0.5, 0.5, 0.5 if we go image to the original. Therefore, our scale factor is 0.5. All right. Hopefully this helps out. Go ahead, try out problem 3. So first off, you're going to look at, is my figure getting bigger or smaller, starting from where the arrow begins to where the arrow ends? Is it getting smaller or bigger? That's going to tell you if it's going to be greater than 1 or less than 1. And then next, you're going to identify the scale factor. Remember, for that, we're going to do the image or the figure 2 side lengths over the original side lengths, or we can think about that as figure 1. So go ahead, try this problem out. See if you get the same thing as me. All right, so I found that the scale factor is 1.5, and then I said that the scale factor is greater than 1, because not only do we solve, but just by looking at it, the shape gets bigger. It's growing. So that tells me it's going to be larger than 1. And some of these will have multiple sides, like we see here, quadrilateral ABCD. Some of them may have 5 sides. But if it only gives you 1 side length, then that's all you have to worry about. So now here you're going to determine for part B if the following statements are true or not. The scale factor from the original to the image is 0.6. So think about how you would test that out. All right. I would go ahead and I'd multiply 7 times 0.6. And let's see if that gives me 4.2. Well, I know 7 times 6 does equal 42. And I have to move my decimal 1 spot, right? Because I moved it 1 spot to the right, so I have to move it 1 spot back to the left. So it would equal 4.2. Could check with a calculator. So it is true because, well, I've showed my work here. Because remember that scale factor is the number we multiply by. You could also test it out by doing (4.2), our image, divided by 7, our original. And that's going to give us 0.6. So that's the other way that you could show your work. Either by plugging in the scale factor or by finding the scale factor like you normally would. Each way is a really good explanation. All right, so now we're going to take a look at this next one. I'll leave that to you. Now here's where the real world problems come in, and I like these because then it gives you an idea of where you would actually use this. So it says Rita is building a scale model of a real castle. Her model has a rectangular base that is 3 feet wide and 4 feet long. All right, so we have a rectangular base. That tells me what shape it's going to be. And it doesn't matter if you draw this to scale, so any rectangle will do. And it's 3 feet wide and 4 feet long. The real castle, okay, so this is just a scale model. Okay, this is my model here. So it's just a drawing. It's not going to actually be legit. But the real castle has a rectangular base that is 150. All right, so this is the new actual real deal castle. 150 feet wide. Okay, so I have to match up my width with my width when I draw my new actual drawing. I'm going to draw it bigger because obviously it's getting bigger. And that's the width. So here it's going to be 150 feet wide and 200 feet long. So notice I have my 3 for my width, and then I also have my 150 for my width. Okay, so they're in the same position. That's so important. And then we have our length matched up with our length. But notice we need to still find the scale factor here. So we have the drawing, but we need to find the scale factor. That's what it's asking for. So how do we get from 3 to 150, and how do we get from 4 to 200? So what I'm going to do is identify this as my image. Okay, because if we were to draw an arrow here, we're going from left to right. And this is going to be my OG or my original. So I'm going to write it as my image side length, 150 over 3. And that would give me 50, 150 divided by 3. Then I have 200 divided by 4. And that also equals 50. So my scale factor, which I'll write down here, when I'm drawing this, is going to be that for every 1 foot that I draw of my castle, it's actually going to represent 50 feet in real life. That is my scale factor, my multiplier. I will do one more down here. I like this one because this one is talking about a map, and this is where we see a lot of scale factor. A scale on a hiking map shows that 1.5 inches is equivalent to 4 miles. So if you ever look at a map, it would say our scale here is 1.5 inches to 4 miles. What is the number of miles that is represented by 6 inches on the map? All right, let's go ahead and set up a proportion here. So I'm going to make sure that I keep my inches on top. That's what I'm going to do. So 1.5 inches is equal to how many inches in this case? And then I'm going to go ahead and write my 4 miles below my 1.5 because they match up together. 1.5 is equal to 4 miles. And then, so how many inches would, we're looking for miles here, not inches. So if we have 6 inches, how many miles would that be? Okay, so what do I have to multiply 1.5 by to get to 6? And I have to multiply 4 to get to a new number here. Now here's a little trick. You can give a variable here. We'll say variable m for miles. And I can multiply across and multiply across. And so now I have 1.5 m. Remember, m is a missing number here in miles, equals 24. And so now I can just divide here. I can do 1.5 divided by 1.5. And I can do 24 divided by 1.5. So now m equals, let's grab our calculator here. Whoops. 24 divided by 1.5. That equals 16. So, how many miles would it be? It would be 16 miles. Because here we're multiplying by 4, and here we're multiplying by 4. All right, I'll leave the rest of the problems to you guys to complete, and then you're going to complete exit ticket 2.1. So I'm going to go over here to exit ticket, and this is the first one, 2.1. Notice 2.2 is on the back side. So here you're going to be talking about if the scale factor is going to be greater than 1 or less than 1, going from left to right. And then you're going to show your work to identify the scale factor. So what is the number that you're multiplying by to get from this shape on the left to the shape on the right? And then same thing down here. You're going to be multiplying by a number that's greater than or less than 1 to get from the shape on the left to the shape on the right. What is the scale factor? Most importantly, show your work. All right, so that's going to be for 2.1. Name goes here. Thank you so much.